The SS theorem is derived in a simple, closed, general equilibrium framework with the following key assumptions. 1. Two goods, X and Y, produced under perfect competition. 2. Two factors of production, L and K, labor and capital, fully employed and perfectly mobile between the two sectors. 3. Technology, constant returns to scale, CRS, and identical across sectors/countries. 4. Zero economic profit. In a perfectly competitive long-run equilibrium, the price of a good must equal its unit cost of production. Mathematical derivation: the zero profit condition. Let Px, Py, prices of good X and good Y W, wage rate, price of labor L, rental rate, price of capital K, A underscore LX BX, A underscore KX, amount of labor L and capital K by, required to produce 1 unit of good X, the unit input coefficients, A underscore LY, A underscore KY, unit input coefficients for good Y. 1. The zero profit equations, since price must equal unit cost for both goods. 2. Differentiating and proportional changes. To see the relationship between small changes in prices and factor returns, we take the total differential of the zero profit conditions. Crucially, under the assumption of perfect competition and cost minimization E, the change in unit input coefficients dA must satisfy a first-order condition. The cost savings from using less of one factor must equal the extra cost of using more of the other. For small changes, this means. Thus, when we differentiate 1 and 2, the change in the input coefficients drops out by the envelope theorem. Differentiating 1, divide by Px and use the original zero profit condition, P underscore X equals WA underscore LX plus RA underscore KX. Closing parenthesis colon. Let hat P underscore X equals frac dPx, the proportional change in the price of X, and hat W equals frac dWWY, hat R equals frac DRR. Let theta underscore Lx equals frac WA underscore LXPX be the share of labor cost in the total cost/price of good X. Let theta underscore Kx equals frac RA underscore KXPX be the share of capital cost in the total cost/price of good X. Since labor and capital are the only factors, theta underscore Lx plus theta underscore Kx equals 1. The final system of equations for proportional changes is 3. The Stolper-Samuelson Theorem, the magnification effect. Assume math BFX is the labor-intensive good and math BFY is the capital-intensive good. This means the share of labor in the cost of X is greater than the share of labor in the cost of Y. Now let the price of the labor-intensive good X increase by a small amount while the price of Y remains unchanged, e.g. a tariff on X. Closing parenthesis colon. Substitute hat P underscore Y equals 0 into equation 4. Since theta underscore Ly and theta underscore Ky are positive cost shares, hat R and hat W must move in opposite directions. An increase in the wage rate, hat W greater than 0, requires a decrease in the rental rate, hat R less than 0. Substitute this into equation 3. This confirms that hat P underscore X and hat W move in the same direction. Now for the magnification. Since theta underscore Lx greater than theta underscore Ly of X is L-intensive, and theta underscore Kx less than theta underscore Ky, Y is K-intensive, we can show that the term in the parenthesis is less than 1. Therefore, the multiplier frac 1 dots is greater than 1. Conclusion: the theorem's prediction. The derivation leads directly to the core SS theorem. 1. Magnification. An increase in the price of a good hat P underscore X causes a more than proportional increase in the return to the factor used intensively in its production, hat W greater than hat P underscore X. 2. Opposite direction. It causes an absolute decrease in the real return to the other factor, hat R less than 0. In intuitive terms, the economy must shift its factor mix to produce more of the now more expensive, L-intensive good X. This requires a massive increase in demand for labor, L, and a relatively smaller increase in demand for capital K. This fierce competition for the preferred factor drives up its price more than the output price, simultaneously forcing down the price of the other factor.